using properties of proportion, we want to find x is to y, and we've been given that x squared plus 2x upon 2x plus 4 is equal to y squared plus 3y upon 3y plus 9. This question had appeared in the ICSE 2020 examination, right? Now this question is a slight deviation from the type of questions we've been doing so far. Now remember, our favorite property of proportion that we like to apply in most of our sums is componendo and dividendo. However, we apply that in a scenario where generally we have something of the format n plus d upon n minus d, and then we simplify it. However, here we don't see it to be, it doesn't seem to be in that format. So, but yet, bear with me, we still will be applying componendo and dividendo in this particular sum. Let's see how. So, let's write our question first. We've got x squared plus, x squared plus 2x upon 2x plus 4 on the left hand side, and on the right hand side we have y squared plus 3y upon 3y plus 9, right? As I mentioned over here as well, we will be applying componendo and dividendo. It's slightly not like our usual sums, right? But so by componendo and dividendo, right? My left hand side, remember the format is n plus d upon n minus d. So what I have is x squared plus 2x plus numerator plus my denominator, which is 2x plus 4, entire thing divided by my numerator, which is x squared plus 2x minus my denominator, which is 2x plus 4, right? And this is equal to my numerator on the right hand side, which is y squared plus 3y plus my denominator on the right hand side, which is basically 3y plus 9, entire thing divided by my numerator here, which is y squared plus 3y minus my denominator, which is 3y plus 9, right? So this is the componendo and dividendo. Let's open up the bracket. So we have x squared plus 2x plus 2x plus 4 divided by x squared plus 2x minus 2x minus 4. On the right hand side, when I open up the brackets, I get y squared plus 3y plus 3y plus 9, entire thing divided by y squared plus 3y minus 3y minus 9, right? Still not seeming like anything is being simplified. Let's just check what we can do. We have 2x over here and 2x over here. Those two can get added. In the denominator here though, plus 2x and minus 2x gets cancelled. Similar thing on the other side of the equation. We have 3y plus 3y and plus 3y, which can get added. And if you really look at this, plus 3y and minus 3y in the denominator get cancelled. So what I'm left with in the numerator on the left hand side is x squared plus 4x plus 4 divided by x squared minus 4. Right. Here we have y squared plus 6y plus 9 divided by y squared minus 9. Right. Now here is where the sum becomes slightly trickier. Here's where it requires you to notice a particular thing. If you see this in the numerator, x squared plus 4x plus 4 is actually the expansion of x plus 2x, x plus 2 the whole square, right? The numerator here is the expansion of x plus 2 the whole square, a squared plus 2ab plus b squared. Denominator here, x squared minus 4. 4 is nothing but 2 squared, so it's in the format of a squared minus b squared, which is a plus b x plus 2 and a minus b x minus 2. So this is what our term here simplifies to. Same way in the right hand side of the equation, the numerator y squared plus 6y plus 9 is actually the expansion of y plus 3 the whole square, right? A square plus 2ab plus b square. And similarly in the denominator here, just like in the denominator of the left hand side, this is a square minus b square, right? So y square minus 3 square, which is y plus 3 into y minus 3. Alright, now finally, again, now next we can see there is an x plus 2 term in the new denominator, and the square will get cancelled with it, so I'll be left with only one x plus 2. And on the other side of the equation, y plus 3 can get cancelled with one of the square terms. Right, so finally now I have in my numerator, in my left hand side, x plus 2 divided by x minus 2. Here I have y plus 3 divided by y minus 3. Okay, so here you guys have another option. You guys could either cross multiply and then find the value of x upon y, or if you notice it's x plus 2 upon x minus 2, y plus 3 upon y minus 3, we could apply Componendo-Dividendo once again. So let's continue by using the properties of proportion. So I can say by Componendo and Dividendo, right? My numerator here is x plus 2 plus x minus 2, and that entire thing is going to be divided by x plus 2 minus x plus 2, right? Remember, I directly did that, I did not use the signs. Or this will be equal to y plus 3 plus y minus 3, the numerator plus denominator, upon numerator y plus 3 minus the denominator, so minus y plus 3, right? Signs will change when I subtract. So now what are the terms that are getting cancelled? In the numerator here I have plus 2 minus 2 getting cancelled. In the denominator I have plus x and minus x getting cancelled. In the numerator here plus 3 and minus 3 getting cancelled, and in the denominator here plus y and minus y. Right, so x plus x is 2x divided by 2 plus 2 is 4, which is equal to y plus y is 2y divided by 3 plus 3 is 6. Okay, so to simplify this further, 2 1s are 2 2s are, so I have x upon 2 over here, and on the other side of the equation, 2 1s are 2 3s are, so I have y upon 3. So x upon 2 is equal to y upon 3. Cross multiply this, I have x upon y is equal to 2 upon 3, and that's what they'd asked us to find. So my final answer, therefore, the ratio of x to y is equal to 2:3. This is my final answer.